Okay, good day, good people. Let us finish strain energy. Let us look at the last application. The last application it deals with shock load. Yeah? Let's look at shock load. When weight falls through a height onto an object, it is called a shock load. All right, and of which it's what I have here. Then I will explain to you what the whole precision of your shock load. But like I said on on other previous videos, your shock absorbers, it is based on these principles as well. Yeah? Please make note that there is no ratio between W and F. You cannot say F equals to W or F equals to 2W. There's no ratio between the two. Now let us look at this diagram and make sense out of it. Right. On this figure here, you are having a weight W. It is at a certain height, right? It is above this collar at point B, all right, having potential energy. What? The collar having the potential what? Energy, because it is at what? At a certain height. Or you can say that W there, it is at the potential energy because of what? Of its position, the height. The load W is dropped through the distance h onto the collar. Now when this mass drops to the collar at a certain distance, now this is what you would realize. You would realize that the collar will undergo a certain shock, instantaneous weight, boom, dropping on the collar. What's going to happen to the collar when this weight drops on it? Now you can tell that there would be an extension from point B to point what? To point C. From this point to point C, there would be what? An extension. This distance from there to here, it is an extension, as I've written there, xt. Why? Because this weight, it stretches what? This column here. All right. Now you can tell that there would be a transference of what? Of energy. We said it that the strain, remember, it is the transference of energy in what? In the deformation. Now here there's a deformation from this point here at B to point C. There's what? Deformation. That means there's a transference of energy. Like we said on the previous videos defining what? Strain energy. Now another thing that we indicated on other videos is that this deformation, it occurs within Hooke's law. Now at the end of the day, when we remove this load, the material has to go back to its shape and size. It still have to go back to that level. And when it goes back to that level B, you'd realize that now the column will experience now the gradually applied load, right, instead of suddenly and all that. Now you will realize that when we remove, then the material will go back to that. Then the process here, it will experience the gradual load. Now if that's the case, now then this is the formula that we will be using because of the transference of energy as a result of this weight dropping on the collar and the collar extending to point C. Right. Then we have this formula because there's a transference of energy. Yeah? There's what? Transference of energy. Now we will be using this formula. Oh, my things now have stuck. Really now? There's a transference of energy. Because of height, we are experiencing there potential energy. PE equals to U. Right. Potential energy equals to what? To strain energy. And this principle, it is actually based on the law of conservation of what? Of energy. Right. It is based on the law of conservation of what? Of energy. The law of conservation of energy, of conservation of energy, simply says you can't destroy, nor you can't create, but you can only do what? Transfer. And if you can check from this point to point B, there's that transference of energy. Hence here the material experiences what? The deformation. That indicates to you that we are having strain energy, because strain energy, it occurs in the transformation. Now from B to C, there's that transformation. Now you can tell that there's what? There's a transference of energy from that point to that point. Now hence we are having PE equals to strain energy. There's transference of energy. Now PE, how do we calculate PE? It is mg. PE, it is mgh. Now strain energy, it is 1 over 2 F squared, it is F x t. Now this is the formula that we'll be using, right? This is the formula that we'll be using. Now after the effect, after this weight has dropped on the collar, then here we are having extension. That means the whole height now, it consists of, it is the whole length or height, final length there. Let's put it this way. Final length, it is consists of height. Height, it is A from AB. Let's write it AB plus BC plus HBC. Right, this is what we have here. And here we can somehow say it is HT. Now if we are having HT, we know as well that mg, it is what? It is W. Now we are having W, open bracket, then HT, it consists of the HAB, then you will write H plus XT, right, equals to 1 over 2 F2X, actually not let's not put the what's this there, the square there. Let's not put the square there. It is 1 over 2 Fx t. Now this is the formula that we will be using to calculate whatever that they want us to calculate. Let's write it nicely with a different color. We are having W. The W, it is made up of mass multiplied by gravitational force. The fact that the weight, it is hanged, right? Hence we are having mg multiplied by height. Then open bracket, height plus xt, close bracket, equals to 1 over 2 Fxt. Now this is the formula that we'll be using to calculate whatever that they want us to calculate. Now let us look at this application here. Let's look at this application of that which we spoke about. Let's take out the data, the given information on this question here, the shock load application. Yes, let's look at it. Good people. I will drop another video regarding it.